is important. It's an odd degree polynomial, so now I do know that the end behavior is opposite each other. Because it's positive, I know it starts high, ends low. So first of all, it wants us to evaluate p of negative 2. So negative 2 cubed is negative 8. Plus 3 times negative 2 squared. Negative 2 squared is 4. Minus 4 times negative 2. Minus 12. So that will be negative 8 plus 12 plus 8 minus 12. Guess what that is? Negative 8 plus 12 plus 8 minus 12. 0. It also wants you to evaluate p of 2, which 2 cubed is 8, plus 3 times 2 squared is 3 times 4, minus 4 times 2, which is minus 8, minus 12. There's again, 8 minus 8 is a 0, 12 minus 12 is a 0, so this equals 0. And p of negative 3, negative 3 cubed is negative 27, plus 3 times negative 3 squared is 9, so 3 times 9, minus 4 times negative 3, minus 12. That's a negative 27, plus a 27, plus a 12, minus a 12, which is also 0. So what do your answers, it should say, tell you about the factors of p of x? The factors are what? Factors are, well, tell me what they are. So you could say a lot of things. You could say, since that was 0, negative 2 is a root. But they didn't ask you to talk about the roots. They asked you to talk about the factors. Right? Since that was 0, you could say, if I did long division, I would get a remainder of 0. That's great, but that's not what they're asking you to talk about. They're asking you to talk about what are the factors. If you know negative 2 gives you a 0, then the factor is what? X plus 2, X minus 2, and X plus 3. And your explanation would just be that since negative 2, since p of negative 2 equals 0, negative 2 is a root, and x plus 2 is a factor. Just say that in a sentence, right? If you knew that, then you just need to write a sentence to do the explain part. Determine the end behavior. So odd degree means the end behavior is opposite of each other. Since it's a positive x cubed, it starts low, ends high. This is like what I say just in passing. But I want to review here the other notation going along with this. But let's sketch it first. So we have a root at negative 2, at positive 2, and at positive 3. Does that seem like it's going to be annoying to anybody? Negative 3 is the, oh, you're right, sorry. Negative 3 is the root, not the factor. Is that going to be annoying to you because that's so tight? Okay. Because we have to make sure we hit that going one way and turn around. But so that's pretty tight. If you wanted to, you could scale it differently, but we're just going to continue to count by ones if you're not bothered by that. That's 2, that's negative 2, that's negative 3. So it starts low, comes through, and ends high. So a couple things here. When we graph this, they want us to label the zeros, which I have done. They want us to label the relative maximum and minimum with coordinates rounded to the nearest tenth. So this is just a general sketch. How can I find the relative maxes and mins? Like the exact coordinate here. and the exact coordinate here. Come on, technology savvy generation. Use your calculator. So if we type in this function, x to the third plus 3x squared minus 4x minus 12. And your table may or may not, if depends on if your relative max and min is at a whole number or not. So if I just graph it on the negative 10 to 10 interval, first of all, my relative minimum here is off the graph, so I need to go down further on my y-axis. So I'm going to make my y minimum like negative 20 and hope that that gives me enough to see. Very good. So pretending that the table doesn't work, if I do second table, it looks like see how this isn't good? It looks like the maximum it gets to right in there is 0. But we all know it's gone above 0. So this is not the best place. So just go to second trace and look for your maximum. Scroll down to maximum. It'll ask you to bring your cursor to the left of your maximum for the left bound. So I go over there, enter. Then it will ask for the right bound. So I move my cursor over to the right and then hit enter. And then it will give me the actual maximum point. So negative 2.5 and 1.1. So if you want to do that exactly, we'd have to move that point up. So we'll do that. Negative 2.5 comma 1.1. Rounded to the nearest tenth. So we've got that. There's no way you're going to get that with your table to the nearest tenth. It's just going to be so much trouble. So I know you guys like your tables and they do have their purpose, but if we want exact calculations, second trace is the way to go. Our relative minimum, so we hit that. Again, bring your cursor to the left of the minimum value. Hit enter. It'll ask you for the right of your minimum value, so scroll over, hit enter, and to the nearest tenth we have 0.5 and negative 13.1. So this one I have to change my graph a little bit, pretty significantly. 0.5 and negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.1. .5 and negative 13.1. So that's labeled. Okay? Which should make sense, because look at your polynomial, and what's the y-intercept going to be when x equals 0? If x is 0, what's the y-intercept when you plug in 0? Negative 12. So it makes sense that that got drawn down to negative 13-ish. Okay? Again, we are counting by ones on our y-axis as well. So anytime you're graphing, make sure you scale appropriately. And I would say this on your Regents too. Definitely use pencil on graphs, because you do kind of slowly adjust as you move forward. So we've got our relative max, min, coordinates. We're all good. Okay? So what I was going to say about this determining of the end behavior. This is a very loose phrase that I use. It's really not official. If you were asked to explain and you said that, you'd get credit for it. We all know what you mean. But sometimes it's written, especially in multiple choice questions, with symbolic notation. So as x approaches infinity, p of x approaches what? So as you move to the right, as your x-coordinates keep growing, what is happening to your y-coordinate? It's going towards infinity as well. And as x, that's kind of means ends high, right? As x approaches negative infinity, so we're kind of talking about the beginning behavior, and we're going left, what's the y-coordinate doing? Right, p of x is approaching negative infinity. So that's the starting low, ending high in sort of symbolic notation. So you definitely need to be familiar with that. Okie doke. All right. Open your test 5. Get out your notes. We're moving on to test 5. Number 21. Okay, another polynomial function. Good. What is the degree of this polynomial? Just look at it. Even. Same end behavior. Is it also an even function? Is the y-axis a line of symmetry? No. So a polynomial has to be even degree or odd degree. No function has to be even overall or odd overall. So this kind of can highlight the difference between that, which we just talked about in the quiz. So we got to look at our roots. -7. So is 1 still an option? No. Is 2 an option? Is 3 an option? No. Is 4 an option? Yes. -2 is a root. Is 2 an option? Yes, because x plus 2 is 4. Yes. 0 is a root. Is 2 an option? No. Is 4 an option? Yes. There's your x. There's your root of 0. I could tell right away, this one's only a 3rd degree polynomial. It only has 3 factors. So I knew that was wrong. This has 4. So that's the one. 22 should be a slam dunk. Take 15 seconds to look at that, and then you're going to vote. Hold up your answer on your mark. It's at go. Yes. Number 3. We can only hope for something. That's just a straightforward rule. 23. Sorry about the scribbles on here. Stats. All right. Game face. Got a little reading to do. The hourly wages of working high school students are normally distributed with a mean of 1050 and a standard deviation of 125. Use the diagram of normal distribution below to determine the percent of working high school students who earn between $8 an hour and $11.75. I don't even need this graph. Why not? What kind of question? What'd you say? Norm CDF is going to give me my exact answer. Norm CDF, min is 8, max is 11.75, mean is 10.50, standard deviation is 1.25. So go ahead and do that. What'd you get, Bo? 82%? Okay, good. Just for the record, though, before we did that, and I don't know how they would do it, but we did do questions like this before we had access to Norm CDF, before I taught you that. So the question would be, $8 is how many standard deviations below 1050? 2 standard deviations, because it's $2.50 below, and that's 2 of those standard deviations. So if you went 2 standard deviations below, you'd be there. And 11.75 is how many above? Just 1 above. So if you added up all those percentages, you'd have that same answer. Okay? 24, another focused directrix question. So, quick sketch. Focus is 2, 4. Directrix is y equals -2. Coordinates of the vertex. I'm just looking at the options, and I'm going to guess it's 2, 1. Right? You want to go halfway between this. This is 4 units up, and this is 2 units down, so that's 6 total. So split that difference, 1, 2, 3, and of course 2, 1 is correct, and our parabola opens upwards. So 2, 1 only allows us to eliminate 4. Opening up doesn't allow us to eliminate anything, because they all open up. The only other thing we have to take care of is 1 over 2 FD. So again, the distance between focus and directrix, I counted as 6. So double 6 is 12, so 1/12. So again, perfect case. If you know your formulas, some of these can be really, really simple. I don't know how you would find that without knowing that. Okay? You just don't really have a shot. Jump to 37. Okay, again, I reiterate, if you are asked to sketch a graph, use your calculator to be as exact as possible, okay? So y equals 0.5 to the x power. If you're going to do the 1/2 to the x power, make sure your 1/2 is in parentheses. And then look at your table and grab some nice points. So 0, 1. 1.5. They're going to get tougher. 2, 0.25. So going backwards is the way to go here. Negative 1, 2. Negative 2, 4. Negative 3, 1, 2, 3, 4, 5, 6, 7, 8. Negative 3, 8. And I'm sort of off the graph. What I do know for my own benefit about an exponential equation, this is exponential decay because the base is 0.5, is that the x-axis is an asymptote, so do not let your graph cross the x-axis. If you kept going, it would never become negative, okay? We start using scientific notation because the number gets so small, but that's not a negative number. If we see it cross the x-axis or cross wherever the asymptote should be, we have to take off points. On this next one, again, you can type it in. Negative 0.5 to the x power. That negative is out in front. My guess is that this is going to be a transformation question because we're still using the same base, second trace, or second table rather. So if I grab some points, I have 0, 3. 1, 3.5, 2, 3.75, negative 1, 2, negative 2, 0, negative 3, negative 4. Probably keep going one more. Nope, maybe I'm out of room. Okay, so something like this. What's this never going to cross? 4, because that's an asymptote. If this graph got shifted up 4, that asymptote also got shifted up 4, so do not let that cross 4. We essentially had a vertical reflection and a shift up 4. And I wouldn't be surprised if they asked us to say that. Describe the graph as a series of transformations. Vertical reflection over x-axis, shift up 4. Identify the intercepts and end behaviors of f of x and g of x. So starting with f of x. The end behavior is as x approaches negative infinity on f of x. What does f of x do, Cameron, as x approaches negative infinity? To infinity. And as x approaches positive infinity, f of x approaches what? As we go this way, what is our y-coordinate getting closer and closer to? Nope. The y-coordinate. 0, right? It's shrinking, shrinking, shrinking towards 0. There is no intercept on that one. And on g of x, really quickly, as x goes towards negative infinity, so does the y-coordinate. As x goes towards positive infinity, what's it approaching? 4. Very good. So your homework is the start of test 5. first section of questions.